In this lesson, we are going to talk about cameras. We have been using one camera, which is a perspective camera in the previous lesson, and we are going to go a little further and discover other usage of the camera. So yeah, we already have our startup running. Obviously, if you need help to run the startup, you can use this link right on the lesson you're looking at right now, and you will see exactly what you have to do to run the starter. Okay, great. So let's talk about camera. If you look at the documentation, the Three.js documentation, you have the links as always at the bottom of the page you're looking at right now. So it's not the right one, sorry, it's inside the cameras page. And you have exactly the same. So you have all the links below. On the documentation, you can do searches for camera. You will see that there is a lot of cameras. We are going to talk about all of them, but we are only going to use two of them. So the first one we are going to see is the camera class, just camera. This is an abstract class. You are not supposed to use the camera directly. The other class like perspective camera and I haven't talked about the rest, but you got it there. Array camera, cube camera, orthographic camera, etc. inherit from the camera. So it's just an abstract class, don't use it directly. Array cameras, this one is interesting. It's to render the scene from multiple cameras on specific areas of the render. This way you can have like a part of a render on this part, another render on this part, and another render on this part with different point of view. This can be useful, I don't know if you're doing like, do you know old multiplayer games where we were multiple people playing with different controls on the same screen, the screen was split. You can do that by using array camera. We are not going to use this one. You have stereo camera, which is, let me show you, it's this one. Stereo camera is, you can use this one to render the scene through two cameras that will mimic the eyes. So it's going to do two renders from two cameras. This way you can use the output, the render, to create like an effect of depth effect for special devices like VR headset, red and blue glasses, cardboard, stuff like that. You know, you do a render on a screen, on a canvas, and you put your canvas there using a smartphone, and you will get one eye looking the render of one camera and the other eye looking the render of the other camera. And this will create a feeling of depth, which is really cool for VR experiences and stuff like that. We are not going to use this one though. You have the cube camera. The cube camera is going to do 6 renders, one forward, one backward, one on the left, one on the right, one on the top, and one on the bottom. So it creates a render of the surrounding. We are not going to use this, but Three.js uses this to make environment maps, things that can be used for reflection, refraction, for shadows and stuff like that. So we are going to talk about this in later lessons, but we are not going to use it for specific project, for exercises or specific lesson. But Three.js uses those cube camera and we are going to talk about this. The next one is orthographic camera. The orthographic camera over there is used to create a render of the scene, but without perspective. Meaning that if an object is very far but in front of the camera, it will have the same size of the same object very close to the camera. You can do RTS game, like, do you know Age of Empires? I know that Age of Empires is not 3D. Anyway, the old Age of Empires at least, but the size of the characters is always the same, even if they are going further or closer, it's the same size. It's for orthographic purpose. And you don't have any perspective. Obviously, you have the perspective camera, which is the one we've been using, but we haven't used all the parameters. So we will go further and talk about the 2 last parameters here. And yeah, so let's use the orthographic camera and the perspective camera. These are the 2 we are going to use in this lesson. First, let's talk about the perspective camera. So I have already my my starter running. I don't need the terminal, so I can hide it. If VS Code want me to, yeah, good. So here is our camera. It's already set. It's a little on the side, like I changed the position with X, Y, and Z, so we can enjoy more depth with the cube. And the cube is the mesh, and the mesh is being updated inside the tick. So if I remove this part, at least comment, my cube is not turning anymore. It's not rotating anymore. So yeah, let's keep the cube rotation so we can enjoy like animation, perspective, stuff like that. Oh yeah, we didn't use all the possible parameters of perspective camera. Here is all the parameters. And obviously, as you can see, we are missing 2 at the end. But still, let's talk about the current parameters in case it wasn't clear enough when we first introduced the perspective camera. The first parameter is the field of view. Actually, it's 75. These are degrees. And it's the degrees, it's the vertical vision angle. It's how much you can see. And it's the vertical one, not the horizontal one. By default, it's how 3GS perspective camera is working. You have other environments where it's on the horizontal part. You even have games that works like this, just like I think old Fallout. I think it's horizontal. There are advantage and disadvantage. We're not going to talk about this. Just remember that it's the vertical field of view. 75 is quite a lot, meaning that if you have an object, for me it's over there, I will probably be able to look at it. But actually, as a human, you have a huge field of view. You can put your hand on your left, you can see it and look straight forward. I can still see my hand. I can perceive it, at least. So yeah, we have a huge field of view. So maybe we could put something like that much. If I do this, I will get a very strange result. Actually, it's not working. Why is it not working? Yeah, it was really too much. So let's say I have a huge field of view of 140, and as you can see, the cube is very, very small. I have a distortion happening, and I created a video to show you that. Yeah, here it is. Here it is. As you can see, I'm animating the field of view inside of Blender. This is a very small field of view. I don't remember, maybe it was like 25 or maybe 15, I don't know. And this is a very large field of view there. And as you can see, the cubes are all distorted. This is due to the render being a rectangle. This is the area where you render will be rendered. So yeah, if you do like a huge amplitude render, it will be squeezed into that render, and this is why objects get really small, and you get some distortion on objects on the left. So you have to find the right value. I recommend having something between 45 and 75. 75 is actually quite a lot, but I like to use this one so I can see all the objects easily. It's up to you. You will have to figure out and try to define the field of view at the beginning of your project, because changing it will mean that maybe you won't be able to see objects that we could see previously. So decide. There are performances reason too, but we are going to talk about this later. The second parameter was the aspect ratio. So it's just the width of the render, which is this part. This is the width of the render divided by the height of the render. You need to provide this because it might change in very specific situations. For us, we just want our camera to show something on the render, so it's obviously the size of the render. This is why we used the sizes object, which were created here, and we put values, temporary values that are 800, 800, and 600, and we are going obviously to improve this so that the render takes all the room available. So yeah, these are the two we already used. Let's talk about the two other parameters we have to add at the end. So where is my camera? Right here. So I will just zoom out a little so we can write it here. The two last parameters, in the example, it's something like this, I think. Maybe 1000. Let me check. Yes, 1 and 1000. These are the near and the far parameters. Any object closer than the near or further than the far won't show up. And if an object is between visible and not visible, well, you will see just a part of the object. What we can do here is try to choose a value that will show that, that effect. Maybe if I put, so my camera is at this distance, I can actually get the distance of the camera by using console log, camera position, and if you remember, we have the length, because position is a vector of 3. So if I get this, okay, this is the distance of the camera. If I use this value in the far, look at this. As you can see, a part of the cube is being invisible. I can lower this value a little, let's say 2, 3.2, and as you can see, we can see just a small part of the cube. All right, so which value should we put here? Me, I want to see everything, so maybe I should do something like this. Yeah, oh yeah, something very large. Yeah, it should work. Let's see if it's working. Yeah, it's working. And I won't have objects that just disappear from my screen. Do not do that. It's a mistake. It's a mistake because you're going to create a bug, a glitch that we called Z-fighting. Z-fighting happens when you have two faces, let's say a blue face like this. So imagine my hand is blue, and a red face like this. So this is the one. If they are far, it's obviously this one that is being shown, and this one is hidden by this hand. But if they are close, which one is in front of the other? It's obviously for us this one. But if you do extreme value like this, your GPU will have troubles to guess which one is in front of the other. And we'll get a bug that looks, I will open the second link, that will look like this. You see the glitch between those? It's when planes or anything, triangles let's say, are too close one from the other. So yeah, you have to avoid this. Another good example. Yeah, see? There is a glitch here, which is the Z-fighting. He put a bin on she put a bin, sorry, on it, so it's hidden, which is a nice fix. All right, great. So which value should we put here? Well, it really depends on your scene, on your project, how close your camera can get. I think we're going to go for something like, I lost it. Yeah, let's try to find something. 0.1 is very close, so we can get we can put the camera close to the cube without the cube disappearing. And here we can use like 100, which is probably too much, but in case we want the camera, I don't know, to fly away and look back at the scene, it's possible. If at a point you think that, oh no, it wasn't the right value, just change the value, it's okay. One good thing with that is that you can automatically not render objects that are too far. This can be good, like, I don't know, if you are doing, you have mountains, villages behind the mountain, in front of the mountains, and clouds very, very far. Well, with that solution, the things too far from the camera won't even be rendered, and it's okay because it was too far. We are not supposed to see them. So it's up to you to find the right value. Okay, this was the perspective camera. All we had added here was those two values. You have to provide those values if you want to adapt them. By default, I think it's 1 and 1000. Now let's talk about the orthographic camera. So the difference with the perspective camera is the lack of perspective, meaning that an object in front of you will have the same size if it's very far from the camera. So how can we use that? Yeah. Let's talk about the parameters. First, we are going to comment the perspective camera, like this. I'm going to let the position, because we can rotate, move, and not scale, but we can rotate and move the camera, whereas it's a perspective camera on an orthographic camera. And we are going to replace this. Keep the perspective camera, just comment because we are getting back to it after. We are going to create a new one, const camera equal, and we are going to use the orthographic camera. Orthographic camera. So what about the parameters? First, we need to provide a left, a right, a top, and a bottom. This is very strange, but it's perfectly logical. We are going to say that your camera is not doing like a cone like that. It's not a render that looks like this. It's more like a square or a box or a rectangle at least, and you will do a render like this, like parallel renders, like this. So you have to specify the distance on the left in which you will render, the distance on the right in which you will render, on the top and on the bottom. If you put a huge value, things will get small, but you will cover a large area. And if you put a small value, you will just render a very small part of your scene like this. And that's all. So let's put some value. I don't know what exactly I'm supposed to put here. So I would do just -1. Then it's the right, if I'm not wrong. Let me check. So it's left, right, top, and bottom. So let's follow those. Left, -1, right, 1, top, let's say 1, bottom, -1. All right. And the two last parameters are the near and the far. And we know about those. Let's use 0.1 and 100, just like the perspective camera. So what do we get? Okay, this is working. As you can see, the cube seems to be parallel, meaning that all the sides are parallel, which is great. It's exactly what we wanted. Unfortunately, the cube doesn't look like a cube. As you can see, it's more like a box that has been squeezed on the y-axis. And actually, I can show you even more. Don't do it, but I will show you this. Let's put a smaller render on the height. Yeah, that's the problem. It seems that the render is stretching the size of the canvas is stretching our cube. If I use a square, my cube looks like a cube. That's working fine. But if I use something else, like say the 800 and 600, I get a bad result like this. Well, this is pretty simple to understand. You're doing a square render. Look at those values. I'm doing -1 on the left, +1 on the right. So it's like this. Then +1 on the top and +1 on the bottom. So I'm doing a perfectly square render of the scene. So I'm looking at the scene and I'm getting everything that's visible in that square and saving it to the render. But my render is not a square. So I have to do something about it. The solution is actually to have the aspect ratio of our canvas, of our render. So we are going to calculate this, and we already did actually for the perspective camera. You can do const aspect ratio, and the aspect ratio will be the width of the render divided by the height of the render. We already done this right here. So it's going to be sizes.width divided by sizes.height. And this, to use this, we simply have to multiply the horizontal, let's say field of view. It's not the field of view, but the horizontal amplitude, or maybe the vertical amplitude. I don't know exactly. Yeah, well, I know it's the horizontal one, but if you don't know, just test. Use the aspect ratio, let's say here, and then be careful where I'm going to put here. So it was the first parameter, and now I'm going to use on the the second parameter, like this. What I can do here is put the parameters right here, like that, so you can see more clearly, and I'll be able to zoom in a little. Yeah, just like this. I don't know if it's better. Don't do it. So yeah, here is the result I just saved, and as you can see, I now have a cube. And what happens here, if you log the aspect ratio, my log snippet is not working anymore. I hate it. I have to fix this. So yeah, let's see what we have in the aspect ratio. I have something like 1 point something, which means that instead of -1, I'm going to have more, which is going to be minus 1.3333. And here it's going to be the opposite. It's going to be 1.333, which is perfect because we are going to render a little further on the left and a little further on the right. The vertical amplitude didn't change, but this is exactly the rectangle of our render, and we are doing a render of the scene like this, and we are putting this inside the render, so it's working perfectly. And that's all. This is a way of doing it, so you have a perfectly projected scene using the orthographic camera. All right, let's get back to our perspective camera. This was just an example. I really wanted to show you the orthographic camera because you might need it. It can also be used to create effects, stuff like that. So I really wanted to show it to you. The example is over. You can comment this part if you want to keep it. In the same page you are looking at right now, you can also download the final project. So yeah, let's get back to the perspective camera, which was like this. Okay, cool. This is great. We have our camera, we have animation, but it's pretty hard to move around. I would like to be able to control the camera and to move, I don't know, just move the camera so I can see my object from different point of view. And to have more control, what's better than the mouse? So yeah, we are going to use the mouse. If I move the mouse on the left, I want the camera to go on the left, and on the right to go on the right, up and down. Okay, let's do this. Command the orthographic camera, we did it, and command the perspective camera. Yeah, move the camera so it faces the cube. So we are going to remove this and this. I will just command them. So we have a better starting point. So yeah, right now my camera is just right in front of the cube, and we are also going to stop the animation of the cube, which is right here. Okay, so just command inside the tick function, just command the mesh rotation y equal elapsed time. I will let the elapsed time, even if I don't think we are going to need it till the end of the lesson. All right, so we are at the beginning, you remember, with the cube in front of the camera, which looks more like a square, but we are going to improve this. Maybe use 3 for the camera position Z. All right, perfect. So if I want to move my camera when I move my mouse, my cursor, first I need to know the coordinates of my mouse, of the cursor. So let's do this. I'm going to put my code over, I don't know, yeah, I will put it at the beginning of the lesson. So right after the import, let the import alone at the top. I'm going to create something like cursor. And I'm going to do everything I need about the cursor. So in JavaScript, so this is native JavaScript. It has, for now, nothing to do with Three.js. How to get the coordinates of the mouse. What we can do is window, and we want to listen to an event. So we want the browser to tell us when an event occurs. And to do that, we are going to use add event listener. Add event listener, you have to provide the name of the event. And for us, it's mouse move, where we want to be alert when the mouse move. It's written like this. No camel case, no dash case. Yeah, it's ugly, but we have to do with it. And then the second parameter, you provide a function. I'm going to use fataro because I always use fataro. I have reason for this, but it's not the subject of the lesson. And in this function, you are going to pass any variable. I'm going to call it event, but you can call it whatever you want. So yeah, let's use event. Inside those semicolon, we are going to log event.clientX, and let's start with that. You can put the event client Y if you want, but let's start with event client X. And look at this. Check your console. So open your DevTools, go to the console tab, and here are the coordinates of the cursor on the X axis, which is working just fine. When I'm at the left corner, I have something like 0, and I'm close to 0 at least. And at the right part, I'm going to close to 1000. Okay, great. And you can test obviously the Y axis, which is important because look at this. When I'm at the top, it's close to 0. and the lower I get, the higher the value. So it seems like the y, the value is going up when the cursor is going down. Keep in mind this. We are going to have a problem with this. We could use those values. Let's talk about the x only for now. We could use this pixel value, but I don't like to use pixels value because if my screen is bigger, look at this. Now I get 2000, which is a lot. If my screen is smaller, because it's a mobile or a small screen, I don't know, it doesn't be beyond 800. So I don't like this. What I want is something that has an amplitude of 1, something that goes from 0 to 1 to start with. Well, to do that, first we are going to, let's first create somewhere to store those values. So I'm going to create const cursor equal an object, just like we did for the size. We saved the size inside an object. It's not mandatory, but I recommend always organizing inside objects. And we are going to create cursor.x equals 0 and cursor.y equals 0. And we are going to update those values. So if we want to start, we're going to do cursor.x equal this value we are logging right now. So I will put it there. And then you can just log it again. Console.log like this. So as you can see, I have the same thing, but I'm saving the value inside cursor x. So I have to update this. What I was saying is that I prefer to have values that goes from 0 to 1, if possible. At least that values that have an amplitude of 1. So how to do this? Well, actually, we can do this easily by dividing by the size of our viewport. And we already have something like this. I think we are going to use this. Yeah, we are going to use sizes.width. It's not the size of the viewport because the sizes, as you can see here, we provided 800 and 600, but in later lesson, this canvas will have the size of the viewport. So we can use these values. All right, and we are just going to test on this area for now. I repeat, in a few lessons, this canvas, this render will take the whole viewport, so we won't have any problems about sizes going above the value, etc. So yeah, as you can see, I divided the event client X by sizes width. And here it is. I have something close to 0, and I have something close to 1 now. Yes, it can go below, above 1, but it's not a problem. I have something that goes from 0 to 1. That's cool. And we can use this, but we will go even further. I want this value to be negative and positive. I want just the value to be able to go to the negative and the positive. To do that, I'm going to use minus 0.5. Why minus 0.5? Well, it's because my value is going from 0 to 1. When doing minus 0.5, the value will go from minus 0.5, positive 0.5. So it can be as positive as negative, which is even better for us because we want our camera at the end to be able to go as much on the left than on the right. You don't have to do this part, but I like to do this. So yeah, let's test it. If I move my cursor on the left, I have something very close to minus 0.5. And if I move to the right, I have something very close to 0.5. So positive 0.5. This is a very good value. You have many ways of doing it. We are going to do that again in later lessons. Don't worry. If it's not very clear, it will be in few lessons. So yeah, let's do the same for the y-axis. So I'm going to change x by y inside the cursor, and also for the client, so event client y. And instead of dividing by sizes width, I'm going to divide by sizes height. Let's test the value because we can do mistakes. If I'm on the top, I have minus 0.5 almost, which is great. And if I go to the bottom, I have something that close to 0.5, which is great too. Okay, I think this is fine. We have our cursor coordinates. We can remove the console. We don't need it anymore. And we can move further. Oh, we are almost there actually. So yeah, let's not touch to this part again. We have our cursor coordinates, which are very, very good. What we can do now inside the tick function, because we want to do that before each render, we're going to update the camera. Update camera, and it's going to be very simple. All you have to do is change the position on the camera, but it has to be on the right axis. So let's try to find them without looking at the slides on my screen. Pause the video, try to find the right axis. It's a good exercise. It takes time to guess the right axis, and get back to the video. I will show you the solution. You have to do camera.position, and it's going to be obviously on the x-axis, so there were no trap, almost. And I'm going to use cursor.x, and let's just start with that. And here you go. It's moving, it's working fine. Okay, let's add more amplitude by multiplying this value by, I don't know, maybe 3. See, I'm going further and it's working perfectly. Let's do the same for the y-axis. Y. I will keep the same amplitude. And look at this. Nice. But wait, there is a problem. My camera is moving. Congratulations, this is a good start. But it looks strange. Look at the axis. When I move left and right, the camera is going in the cursor direction. But when I move up and down, it looks like it's more like the cube which is following the cursor. Remember what we said earlier. The event client Y is being positive when going down. But in Three.js, the y-axis is considered to go up. So we have to invert something somewhere. You have multiple choices. You can do it inside the mouse move event, or you can do it while using it here. I don't have a preference. You can do, let me think. Yeah, in the example, I'll do it in the event. So let's do it in the event. Yeah, I told you we weren't going back to there, but we are. So instead of just putting minus here, it's mathematically wrong. You have to put parentheses around everything. Okay, it's just math. So this value is now negated. Negated, I hope it's a word. I'm going to save and look at the result. Yeah, that's it. The camera is moving. It's working nice. You can see the cube from different angles, which is great. Let's go even further. We are going to ask the camera to look at our cube after moving it, so that we are always centered on the cube, regardless of the camera position. To do that, you will simply call camera.lookAt. You know this one, and we need to provide a vector3 here. So we can just create one, new 3.vector3, vector3 like this. And if you don't put anything in the values of vector3, it's the same as putting 0, 0, 0. So we can just do that. I save, and yeah, this is working fine. Let's add more amplitude. I don't know, a lot. Let's say 10. Yeah, this is working perfectly. Our camera is moving like if the camera were on a plane, like a plane, a flat plane, not a plane that can fly. So yeah, it's working fine. Instead of creating an empty vector3 on each frame, because this is what we are doing right now, I can use the cube. So it's going to be mesh.position, because we are not moving the cube, and the cube is at the center of the scene, which we get the same result. All right. This is great. Let's go even further. This is great, but I cannot see the back of the cube. Look at this. I have the front face here. I can see on the side, the other side, the top, the bottom, but I cannot see behind the cube because of my camera animation right now. what we are going to do right now, it's just to practice for exercising and do some mathematics. We are going to rotate our camera on a circle around the cube. So this is our cube. Right now we are just doing this like that. I want to go all around the cube. So it's gonna be trigonometry with cosinus, sinus, and math pi. Why math pi? Because I want to be able to do like a full revolution around the cube, a perfect full revolution, not more, not less. So if you remember what we saw in the previous lesson, if you use cos a value, you get something like this. So if the value increase, you get oscillation like this. And if you use sin of the same value, you get almost the opposite because it starts at 0 while the cos were starting at 1, and you get the same waves. When you combine them, let's say you use the cosinus on an axis and the sinus on another axis with the same angle, you get a position on a circle. So if I use, so first question is, what are the axes we are going to move? So this is your cube. What are the axes to position our camera around the cube? It's going to be like on a plane there. So I'm not going up and down. It's just about positioning like this. So it's going to be X, which is this one. So it's the opposite for you. It's this one, and Z, which is going that way, I think, to you. So it's X and Z. So yeah, let's do this. We are simply going to position on a circle by using math.sin. And for the other one, which is not this one, we are going to focus on the Z. So it's going to be, it's not going to be Y, it's going to be Z. I'm going to use math cos. And you can mix them actually, you will get a very similar result. It's just like the base angle that will change. And we are going to provide a value here, and it has to be the same value so that our result will be a position on a circle. We are going to do that multiple times. Don't worry, at the end you will know about trigonometry if you don't already know. So yeah, what angle are we going to use? Well, I'm going to use cursor.x, because when I move, look at this movement, don't look at the camera, the current camera animation. When I move my cursor like this, I want to move around the cube. So I'm going to use cursor x, and I'm going to use the same value on both sin and cos, like this. Wait for it. Okay, so it seems to be working, but the result is very strange. There are multiple problems right now. First, the amplitude is very small. Like we are just doing this, like that. Yeah, we want to do full revolution around the cube. To fix that, first we need to multiply the value, the angle we provide to sin and cos. I could use something like 10. So right now it's working. Very strange, but it's working. Remind me of Tron, you know, the first Tron, the big boss at the end. I'm too old. So yeah, it's working. We are going to change this one after. So yeah, the problem right now is that we are very close to our cube, because sin and cos return a value that goes from -1 to +1. Okay, so all we need to do is go further by multiplying the result, not the angle inside, the result of math sin and math cos by something, I don't know, maybe 3. Let's test it. And here you go. This is working nice. We can go all faces of our cube. Actually, no, we cannot see the top one and the bottom one, but we are going to fix this. So first problem is that it's not doing one revolution, I'm doing a lot of revolution. So if I go from here, I have 1, 2, 3, 4, 5, 6, no, I just need 4 faces, meaning that I'm doing one revolution. So how to do that? Well, I already told you about this. We are going to use math pi, because pi you can use pi to do half a rotation. So we're going to do math, instead of 10, we're going to use math pi multiplied by 2, because we need not half a rotation, but we need full rotation. And look at this. So I will start at the left. I have 1, 2, 3, 4, and I get back to the first. I have a full rotation, which is really nice. Starting to look great. So yeah, we are almost there. What we need to do now is be able to see above and below. And to do that, we are going to play with the Y position. So I'm going to use Y equal, and it's very simple. Look at this, cursor dot Y, because don't forget, we are using only cursor X for the circle rotation. Let's use cursor Y to position vertically. It's working, but the value is too small. Let's multiply it by, I don't know, 5 maybe. I really don't know. It's oh yeah, it's working great. As you can see, I can see above, below, on the left, on the right, and turn all around. Okay, that's great. Don't forget to put the look at after updating the position. If you say your camera, look at this, and then you move it, it will not look at the things you wanted. Okay, we could go even further. One cool thing would be able to go to the cube, maybe to go back, maybe to add some easing, stuff like that, if you know about those. But it's too long, it's too hard. What we can do is use built-in controls inside Three.js, because yes, Three.js has built-in controls. So we just have to instantiate the right built-in controls, and you will have the same kind of result and even more. So yeah, let's go. Let's see all the controls we can use. Go to the documentation and simply write controls with an S. That doesn't change anything. Anyway, so here are all the controls. We are going to talk about all of them, but we are going to use only one of them. So yeah, let's go. The first one is device orientation control. This one is used when you have multiple usage cases, but it's mostly with smartphone like this. When you use the device orientation controls on a smartphone like this that has device orientation, you will be able to control the camera and you will be able to see the things moving while you move your camera like this, which is very immersive. So it's really cool. You can do without it, but you will gain some time by using it. The problem is that currently, at the moment where I'm recording this, iOS stopped supporting device orientation. I don't know why. That bothered me a lot because we could do like really cool things with it, but device orientation won't work on iOS. That said, let's talk about flight control. It's not in the same order, you will see why later. So yeah, flight control. We are going to test the example directly and you will understand. Yeah, each time you have examples. So for device orientation, well, I didn't use the example because I'm using a computer. I don't have device orientation on the computer. For flight control, you can test the example, pause the video, test the example, and you get something like this. So I can open it a little larger, yeah. So I can fly like in a spaceship. I can go up, down, but also I can rotate like this. Do a barrel roll, as I say. Yeah, I'm really too old. It's Star Fox. Oh yeah, this is flight control. Should have been more like spaceship control, but why not? The next one is first person control. Don't get too excited. This is probably not what you're thinking. First person control is like flight control, but you cannot change the up axis, meaning that it's like a bird. You don't see bird doing this all the time or being upside down. So this is the result. You get this. So it's useful for plane if you cannot do a barrel roll. Okay? Yes, I know I have trouble saying barrel roll. So yeah, it has nothing to do with FPS game. It's not first-person shooter style. It's just like a bird or a plane that cannot do this. All right, next one. It's going to be pointer lock control. This one is really cool. No, it's not the one. Yeah, that's it. Pointer lock looks like this. This is immersive. I can go forward, backward. If you're testing this example, you can use the, so for me it's DeadQSD, for you it's going to be WASD. So I'm using a French keyboard. I don't know if you can see. So yeah, it's not exactly the same letter, so it's harder for us. We always have troubles. And you can jump and do stuff like that. Unfortunately, the pointer lock controls is all about making the mouse disappear, because as you can see, there is no mouse currently on the screen, and getting the mouse movement, even if we cannot see it, to update the camera. So what you are looking at right now, it's not just the class being instantiated. It's also the developer who did this example did more, like controlled with the keyboard, updating the player according to the keyboard. When the player press space, it jumps, having some kind of collision. Let me show you. If I go to the cube, oh no, bad example. If I jump on the cube, I stay on the cube, so you can play and try to get up. And you see that it's a real challenge. So yeah, I would not use this one because fetching the mouse movement and locking the mouse movement is not that hard using JavaScript. I put the link of the API for doing this in JavaScript. So it's up to you. Next one is Orbit Control. And this one is really great and really handy. Orbit controls look like this. You get something like this. It's smooth. You can rotate. You can move like this. You cannot go below the floor. You cannot go above the angle, like you cannot go upside down. And you have many other features like zooming in and zooming out. So it has nothing to do with those pyramids. Sorry. It's all about the camera movement. So this one is really cool. And we are going to use this one together. And yeah, the next one is going to be trackball control. Trackball control is like Orbit Control, but there is no limit. Look at this. I'm going up, and I can keep turning like this indefinitely. So if you don't have like a floor and a sky, and you want the user to be able to do loopings like this, you can. So it's trackball controls. You also have another control that is named transform controls, but this has nothing to do with camera. All right, this transform controls let you do things like this. See, I can move the cube, so it can be like an editor. I can create an editor using transform controls. Actually, we are going to talk about this, but this is not the point in that lesson. It's going to be for a later lesson. And the last controls, just like transform controls, has nothing to do with the camera. It's to move object, let's say on a plane facing the camera. It's a little like this. So I can just move objects by using drag control. So it has nothing to do with the camera for us. So yeah, let's use the Orbit controls. Orbit controls, as you saw previously, is very similar to what we did in the lesson just earlier, but better, just better. With a better feature, I can go above, there is a limit, and you see it's really smooth. And we're going to implement this. So yeah, let's go. 10 minutes, okay. So let's start. First, we're going to comment the part where we update the camera in the tick function, because the camera is going to be handled by this class. All right, so we don't want to mix our way of updating the camera with the Orbit controls way. So yeah, command this part and command the look at too. I command everything. You can remove it. What I get is my camera facing the cube. So how do we instantiate this Orbit control? Unfortunately, it's not going to be that easy. The Orbit controls class cannot be accessed with 3.orbitcontrol. You can try. Console.log 3.orbitcontrols. Let's just test. And as you can see, I get undefined. Orbit control is part of the documentation. It's part of Three.js, but it's not inside the 3 variable when you import it just like this. So yeah, what are we going to do? Well, because we are using Webpack with modules, we have access to very specific modules inside Node modules. And this is why we use this way of coding, this structure with Webpack, NPM, modules, stuff like that. So yeah, let's use this. Actually, you can find it. I'm going to show you where it is. You don't need to do it on your side, just look at my screen. I'm going to 3. I'm going to examples. I always forget the path. It's going to be GSM, then controls, then pointer lock. Oh, it's not the right one, sorry. It's orbit control. Don't watch those slides. It's going to be orbit control. So yeah, right here. So we have also the TypeScript. I'm not going to talk about this. So to import this class, which is in Node modules, 3JS, examples, GSM, controls, orbit controls, all you have to write is import, use this orbit controls, like this. So don't forget the semicolon, from, and you will do the whole path we just said without the Node modules part. Okay, don't put Node modules, just 3 dot examples, sorry, not dot, slash GSM slash controls slash orbit controls dot GS. And this will give you access to the class without writing 3. So I will now remove the 3, and as you can see, if I got it right, yes, I have access to this class. I don't understand this code. Anyway, I don't have undefined or null or an error. So yeah, this is fine. We can now use this constructor, this class. So let's create our orbit control, and we are going to create it somewhere after the camera. Yeah, we can do it there. Yeah, just after the camera. I'm going to do controls and create orbit, or I think I will just call it controls. Yeah, controls equal, and it's going to be new orbit controls without the 3 variable. It's just orbit controls because we imported the orbit controls only. Where is it? Yeah, right here. You need to provide 2 things to that class. It's going to be your camera, because orbit control is going to update the camera. You have to say this is the camera you have to update, and you also have to provide a DOM element. And by DOM element, I mean an element somewhere in the page that will serve as a reference to put a mouse event on it. Because orbit controls is going to do the same things we did, which is listen to mouse move, but other events like mouse down, mouse up, and even the touch, because you can use the orbit controls with the touch devices, like on your smartphone, iPad, stuff like that. So yeah, we are going to use the canvas. And we already have our canvas somewhere like, yeah, that's the canvas. So just send the canvas like this and look at the result, drag and drop. So I press and drag and drop. And as you can see, I have full control over my camera, just like this. So you can drag and drop, we'll see that later. Drag and drop with the right click, which means moving like on a plane, like that. You can zoom in, zoom out with the wheel. You can also change the default target. As you can see, my control seems to be looking at the center of the scene by default. You can change that by changing the controls.target, which is a vector of 3. So you can just change its axis, and I can change like the y-axis and put, let's say 2. So it's slightly above my cube. Unfortunately, nothing is working. It's because when you change the target, you have to update the controls, and we can do that by calling update like this. And right now it's looking above. So if I look slightly less above, you can see that I'm just looking right above the cube. So let's not use this. And let's go even further. Yeah, as you can see, this is working just fine, but it's kind of harsh, meaning that it moves really like just as I say. If I move fast, it stops fast, and It's really like the movement of the mouse. We can add what we call damping, and we saw the damping in the example, which is right here. Look, there is a damping, which means that there is like an acceleration and also friction, something like this. I don't know the exact calculation behind the formula they used, but it feels really smooth. Okay, so let's add this damping. To add the damping, it's quite simple. You just have to say controls, enable damping, I think, and it's a boolean, so you have to pass it to true. Oh, it seems to be working, but that's strange. As soon as I stop dragging and dropping, it stops. The problem is that the damping has to occur even if my mouse isn't drag and dropping. The controls it needs to be updated on each frame in order for the damping to work. And to do that, what you need to do is go to your tick function, and in the close to the camera part, so before doing the render as always, I'm going to do update controls, and all you have to do is call controls.update. If you are using the damping, don't forget to update the controls on each frame, just like this. Look at this, I now have controls with damping, which feels really cool, really great. So yeah, there are many other properties, methods, stuff like that in the Orbit controls. What I recommend is to always read the documentation just to know that those functionalities, those features exist. So just read the different properties, and you will know that they exist. You can control the zoom speed, the zoom limit, put a floor, and you can go below the floor, stuff like that. And you can control the damping if it's a very smooth damping or not. Okay, great. So when to use built-in controls and when to use custom controls. It really depends on you, on the projects, on the limitation, on stuff like that. If one controls can do everything you need, just use it. All right, if it has no withdraw, it's not too heavy in terms of weight for the file, and just use it. But if you have, let's say, one feature missing in those controls, like I don't know if you'd like to change a limit or stuff like that, and you cannot change the limit of the controls, well, you will have to redo everything on your own, or you will have to dive into the class and change this class so it can handle this feature you need. So it's really up to you. Just check if the controls you're going to use has all the features you need.